thank you very much for having me. When Matteo asked me to give this talk, he said, Robert, can you give a 30-minute talk? And it happens to be about MCP design principles. This is actually a 1-hour talk, and look at the panic on his face right there. So he's going to correct me and say, well, actually, Robert, no, it's a 30-minute talk. And this is probably the interaction that you have with your AI agents all the time. We say, you're absolutely right, it is 30 minutes. I think I submitted this talk back in February, maybe March. And the state of the world, especially in the sort of the landscape of AI, is very different from February until now and May, right? Back then, the question was, is MCP going to be the accepted standard? I have opinions on that. We can talk about that a bit later on. The question now is, it kind of is the accepted standard now, but there's a debate, is should we use MCPs or should we use CLIs, right? Which is more efficient? Now, this talk is not going to tackle that. If you want to discuss that, I'll be outside afterwards. We can share opinions on that. You know, I've already shared a lot of opinions with some of you in the audience already about this. But instead, we're going to go down the MCP path. If you are designing MCP servers, especially internal MCP servers for your enterprise organizations, let's at least do it right. Let's not make some of the common mistakes that I've seen out in the wild, right? So if we kind of look at the way things are at the moment, what's wrong with a lot of the MCP servers that I see out in the wild at the moment, it starts with, we all have an API, right? This is the thing that we're trying to interact with. This API exposes a series of endpoints, right? We have some workload deployment endpoints here as an example, right? So the thing about this is APIs expect deterministic clients. So we, as humans, we know that in order to achieve a certain goal, we must call these API endpoints in this specific order. It's sequential, right? And it will then go and take action against a target platform. That could be a database, that could be a Nomad server, that could be a Vault server, it could be any platform, a cloud provider, any platform, right? And this is sort of the RESTful API way of looking at things, and that's mostly sort of CRUD orientated around resources. What most MCP servers are doing that I'm noticing is they are exposing the exact same endpoints that the API exposes as tools within the MCP server, right? And don't get me wrong, it works, right? And this whole talk is, I guess, my thesis, because I'm not the authority on what good design looks like. This is just my opinion based on my years of experience building APIs and now my learnings in this new AI world, because none of us are AI experts yet. But MCP changes the execution model. This is why I believe this is a mistake, right? So when we think about traditional software, I mentioned deterministic clients, and the first one being us, right? So you have the human being. Now, we have the knowledge of the things that we need to do and the order in which we need to do it. We understand when we get a response from the API, how to interpret that, what we should do next, and we can branch our decisions based on those things there. You've also got things like CLIs, which, again, we as humans tend to be the ones operating them until agents got involved. And then we have Terraform providers, right? Terraform providers will often abstract a lot of this orchestration into its workflow. So you can just declare the desired state within your Terraform, just express yourself, and Terraform goes ahead and it interacts with the API. You also have things like SDKs as well. Again, a lot of these things abstract away the complexities of orchestrating these API endpoints. And let's not forget CI pipelines, which we as humans tend to build. So if we bring this a bit more into practice, let's have a look at a practical example. So a lot of this talk is centered around a deployment platform. It deploys workloads to a server, right? So we have this API, and it exposes these 4 endpoints. And in order to roll back a workload to a previous version, you must make these calls in this specific order. You have to get the previous healthy release. You need to create the rollback release, you need to create the deployment, and then you need to delete the current deployment as well once the rollback is in place, right? Now, we know this, right? If you use this API and whatever APIs you're using, you know these things. That's totally fine, right? Agents don't really know these things, right? But we're managing the logic, and we can choose action based on context and more complete information. If we get errors, if we get issues, we know how to handle that. If you change those clients to agents, they behave differently, right? So they operate with incomplete information, right? They reason about a goal, and then they take action based on the incomplete information that they have. And they adapt their workflows dynamically, right? Where you've got APIs which are designed for deterministic clients like ourselves and the examples I gave previously, agents make it awkward. These are reasoning systems. They're not like us, they're reasoning systems. They reason about a goal, and then they'll do whatever it takes to get to that goal there, right? So MCP in itself is designed to solve that problem there, right? It's a standard way for agents to discover the capabilities that the API would like to expose to the agents. So these are structured tools, resources, prompts. There's so many different aspects to it, right? But the main thing is it's contextual interaction between the models and the system that you're trying to interact with, right? But most importantly, MCP, it shifts the orchestration from the client, which in this world is now going to be the agent. And that makes things a bit safer for us to actually trust the agent to interact with our target platforms via, right? So if we kind of dive into APIs, models, there are so many different models out there, but we're just going to look at three of the main ones that are in use today, right? And I'm sure you're all pretty familiar with this. So the first one is REST. We've talked a lot about REST. It is resource-based. It uses verbs like get, push, getting my words mixed up. Get, put, delete, post, verbiage kind of use, and it's based on CRUD operations, right? Then you have SOAP APIs. This is very common in the financial sector, and that's because it's very rigid, right? It's contract-based, and in financial systems, this is something that is often required for the security and the safety of the outcomes that they need in their processes. And as a result of that, the workflows are very explicit and they're predefined at the point of actually designing the API. Right? And then the third type, which is very popular in a cloud computing age, is gRPC, which is function-based. And the idea is you must know the exact function that you need to invoke, right? So when you start giving agents the responsibility to interact with gRPC, there is no telling which functions it's going to evoke there, right? So these are like three of the most popular models that you see deployed out in the wild at the moment. But the thing that all three of them share is these assumptions, right? That the caller knows how to control the workflow. We have a mechanism to maintain the state, and it knows how to handle errors, retries, and branching logic. So when you get a certain result, what do you do in this case here? different use cases as well. You have GitHub has an MCP server, Figma has an MCP server. They put it out there for their customers to use. I think their use cases are very different to an enterprise who is building an MCP server so they can use AI within their organizations for their own internal APIs. I'm mainly targeting it at that, right, rather than the sort of public consumption ones, right? But the three anti-patterns that we tend to see is people turn their MCP servers into CRUD tools, right? Exposes low-level mutations, which can be quite risky when you have a reasoning agent involved in the loop. It expects the agent to orchestrate the workflows, and the reasoning becomes very, very ambiguous, right? And it's not very safe in the sequencing because of that ambiguous reasoning. Next is thin API wrappers. So they take the API. I've even seen people build tools that literally points at an open API spec and then builds an MCP server based on that. Please don't do that. Right? This is just a one-to-one mapping of the API endpoints, and it exposes them as tools, right? And the main issue with that is the tool surface becomes very, very large, right? And as a result of that, it creates a very high context window. And in this day and age, that's high token usage, and that's the money, that's the gold, right? The third thing I tend to see a lot is overexposed power, right? So when you give the agent too much authority to mutate your systems, right? That becomes risky because, as I gave the example before, it's a reasoning agent. It decides dynamically what actions it's going to take, and they will do that based off incomplete information. But the most important issue with this mistake in my mind is you are placing trust in the wrong place, right? The trust should be around the platform, not the model, right? Whatever LLM you're using, that's not where you put your trust. It should be in the platform that you're orchestrating against, right? So now that we've talked about everything bad, how do we actually go about solving and making this look a bit better, right? So what we want to do is we want to implement something we call capability-orientated design, right? There's 4 principles involved in this. We're going to walk through those 4 principles one by one, right? It's a different way of thinking about our MCP tools. So the first capability-orientated design principle that we should invoke is thinking about capabilities, not primitives. When you look at those API endpoints, these are very domain specific to that API. It's got all of the implementation details baked into the way that the API is constructed. We don't need to think about that when it comes to MCP. We need to think about the capabilities we want to expose, not the primitives, right? So again, I will stress this. I am not saying forget everything we learned about APIs. No. Just park it to the side for a second because you're going to need that knowledge a bit later on. But for now, we need to think about MCP and that execution model and how we make that safe and valuable to us. Right? So here we have an example prompt, right? So deploy a certain version of a payments API patch to the staging environment. Now, this is prompt abuse, frankly speaking, right? And the reason why it's prompt abuse is because the system dictates that you should deploy it to a dev environment first, and you should promote the workloads up the environment stack until you get to prod. So to go straight to staging, that violates the rules, essentially, right? But in the LLM's effort to please us, it will do a few things, right? So it will go ahead and create a release, which is fine. It will specify the target environment, which is not fine, right? Because what it should be doing is getting the target environment. If it goes and gets the target environment, it will turn around and say, well, the target environment is dev, right? It will then create the deployment, and maybe, just maybe, it will update the environment state, right? And this is what happens when you give either API access to the agent, or from the MCP's perspective, if you expose low-level mutations, right? And that's if you're lucky. It can do some wild stuff, believe me, right? It could also create a deployment with a stale state. For example, it skipped the create release step, for example. So it would just go and grab like an old stale state, and you'll be wondering why customers are calling up saying, oh, the app is not working properly. And it's because your agent hasn't done things in the deterministic manner in which you intended it to operate, right? So the tool needs to abstract the correct orchestration workflow. Do not leave it up to the agent to decide what order to call these endpoints in. You make sure that all of that is abstracted away in the way that you give it the tool. So what does that look like? So here we have two capability examples here, right? So the first is to deploy an application, and there are 4 API endpoints that need to be called in that specific order. From the agent's perspective, it doesn't really need to know about those endpoints, and it won't. All it knows is that, you know, when it fires up and it loads the MCP tools into its context, it knows that I have deploy application as a capability, right? And when it invokes that capability there, it will call those endpoints in that specific order, and it manages the whole workflow for you. The same thing with promote environment. There are a few different endpoints that must be called in this case here. And again, totally fine. The agent does not need to know about these things here. You're just going to load this into the context window, and this all happens automatically when you start the agent and the MCP server is configured for that agent. So this is what you want to do. Forget the primitives for a second. Think about capabilities. What is the end goal you want the agent to achieve? And then you abstract that workflow into a capability so that the agent can consume that and invoke that. The next design principle we'll discuss is intent-based interfaces, right? And to understand this, we should probably look at MCP tools and some of the interfaces that go into creating these tools here, right? So there are essentially 3 main components when it comes to an MCP tool, right? So a name, a description, and a JSON schema, right? These are the main interfaces that are going to guide the agent into deciding whether it should invoke the tool or it should invoke a different tool, essentially, right? So if we look at some bad examples of names, right? A capability called update deployment probably isn't great, right? And the reason why is it's very vague. You know, you can see the reasons on screen. It's mutation orientated, very unclear what the operational goal is, right? Are we trying to update to a new version of the service? Are we trying to roll back? What are we trying to do here? It's ambiguous, essentially. Very unclear operational goals, and the safety implications, it's very hard to tell what the risk is there. Now, in terms of the description, this very, very brief description doesn't really tell the agent much. Updates an existing deployment, right? So whilst it's mechanically accurate, it is semantically useless, right? It doesn't tell the agent anything that guides it in the right direction, right? There's no operational meaning behind this. There's no guardrails or constraints behind this, and the intent, there's no guidance for the agent there. And then the third element, the JSON schema, this is a bad example as well, right? Very small, very high level, literally just saying deployment ID and payload, right? What does that even mean? What does a payload look like, right? And the problem with that is this arbitrary mutation surface, very, very ambiguous, and the agent must infer what changes are allowed. It's impossible to reason about the safety of this here, and it's weak, if any, operational semantics. This is the JSON input schema. If you look at the output schema, this is, I don't know if it's just as bad or even worse, but just to turn around and say success is meaningless. That it tells us nothing about the operation. There's no indication of the outcome, no indication of the safety or the rollout status, the approvals, the health, the resulting state. It tells us nothing. All it says is success, right? So if we see what good looks like, rollback application is much better than update application because it tells us exactly what we're trying to achieve. Operationally, we're trying to roll back to a previous version. Now, the reason why this is good is it's explicit, it has a bounded meaning, and it clearly communicates the purpose, right? It implies safety expectations as well, and it strongly guides the reasoning agent, right? So with a name like this, the agent immediately understands what the desired outcome is, the operational domain, and the likely risk level of such a change, and the workflow semantics that are actually behind it as well, which helps, right? If you look at the description, again, this description is a lot longer and more coherent than the bad example that we just gave before. And the thing that's great about this description is it communicates very clearly what the operational intent is, and it explains the constraints, right, as well as the platform responsibilities. Removes all the ambiguity, and it teaches the agent how to think about this capability, right? And this is a good example of a JSON schema. I apologize, it's probably a bit small, but to fit a good schema on this slide was pretty tough, right? But the reason why this is good is because it has meaningful fields, right? It's broken down in a way where the agent can understand exactly what's happening. It has bounded operational scopes and constrained environment values, right? The intent is captured very explicitly, and it has very descriptive guidance, right? So what you have to think about when it comes to these schemas is it becomes part of your operational contract. This is simply not just validation, right? This is the operational contract, right? So this is good JSON input schema examples. Here we have a good output example here, right? So much better than success, which didn't tell us anything. This one here gives us an operational meaning. It's outcome orientated, observable, auditable, agent friendly, and it communicates a few things. It communicates what happened, what the state is now, and what follow-up reasoning may be needed, if any, right? And the main point here is the MCP schemas, they are not just validation contracts, right? They are reasoning interfaces and the behavioral guidance systems for the agents themselves. So that's super important that we don't miss this opportunity when we're actually writing up these schemas here. The third principle is minimal capability surfaces, right? So this one's pretty simple. Every tool that you add to the MCP server increases the capability surface, right? And let's look at that in practical terms, right? So whether you consider these to be small MCP servers or large MCP servers, we are not going to have that debate. I'm not going to die on that hill. This is just an example, right? On the left, we have a small MCP server. It exposes 10 tools, 10 capabilities, right? On the right, we have one that exposes 100 capabilities, right? So clearly the one on the left is smaller than the one on the right. So now what happens is when you configure your agents to load these MCP servers at startup, essentially what happens is it loads every single capability into the context window, right? And the more tools that you load into the context window, the more token usage that you have there, right? So an estimation here, and I know the range is a bit wide. That's because the number of characters in each name, each description, so on and so forth, will vary for each capability. But that small MCP server example will load anywhere between 3,000 and 8,000 tokens into the context window versus the large one, which is 10x that, right? So think about the people that are going to be using this. Think about their pocket as well. We're subsidized at the moment as we use these tools, as we use Claude Code, as we use Cursor, and we use Codex. This is all subsidized at the moment. At some point, they're going to turn off that subsidy, and we're going to have to pay full whack. And that £20 a month that a lot of us are paying, some of us 100 or 200, it's going to go up, right? So can you imagine when you're consuming so much of that through just loading an MCP server? We have to think about these things here, right? So try to keep your MCP servers as small as possible. Only expose capabilities that you intend to be invoked by the agent. Do not expose your entire API endpoint unless you have a good operational reason to do so, right? And the last one is observable operational intent, right? So how many people here will give their agent a goal, say, do this thing for me, and the agent will go ahead and it will plan and it will do all these designs, whatever it is, and it will write all this code and say, do you approve this? How many of you actually read all of that code? How many of you just get tired and be like, yeah, looks good to me? I hear the laughs, so, you know, I'm not alone, right? When something goes wrong, how do you figure out what went wrong, when it went wrong? Because sometimes issues happen, and it's not through a change that I did today. It's a change I did 4 weeks ago, and, you know, it's only just come in to bite, right? How do you figure these things out? If you have audit requirements, for example, your auditors need to understand what's happening, how do you prove what happened, right? So it's important we understand, whether it's troubleshooting or auditing, what happened, what changed, why it changed, when it changed, right? And to do so, we need to capture that operational intent, right? So this is just the good JSON input schema example. With this, we're already in a good shape, right? We're already starting from a place of strength. And the reason why is because one of the fields in this input schema is reason. The agent needs to provide a reason why it's invoking this capability, this tool, right? And if you look at the required fields section at the bottom, it specifies reason as required. It's not optional. So the agent will not be able to invoke this tool without providing a reason, right? But that alone, that's not going to be enough, right? We need to provide the full picture of what, when, and why, right? So we also want to capture almost like logs, right? We want to capture the invocation, right? And this is just an example of some of the data that you might need to capture there as well. Obviously, there are IDs because you want to do some correlation and so on and so forth, what the capability is, the decisions that got made, the policy decision, the status, and the resulting summary. This is just an example very specific to my deployment example here of deploying workloads to a target platform. Your invocation logs will be specific to your platforms, whatever you're building an MCP for, right? So we want to capture the full event picture when it is invoked, right? Not just the reason, but what this reason is referring to. And this log, along with that, should provide that, right? So get a response structure, figure out what that looks like, and then design that log structure in your MCP server, right? You have it, but you need to store it. It's all good having logs that stream on some standard out terminal somewhere, but you know, when you need to access it, how are you going to do that? If it was a year ago, how are you going to do that, right? So storage becomes a big thing, right? And again, I don't really see people building this into their MCP servers that often, right? And there's kind of three main ways, there's other ways, but there's three main ways that you can store this operational intent, right? And the first is databases, acts as a system of record, is very well understood by most of us in this room. Postgres is very, very mature. It's very easy to build relationships within those data structures there. It's just all around very, very powerful, right? So that's one option for storing your operational intent. The next is structured log aggregators, right? So this is sort of like a system of operational events, right? Slightly different to a system of record, but it allows us to reconstruct the timeline of events that got us to a certain point, which can be really, really valuable if you're, I don't know, if there was some sort of security incident and you were trying to assess what happened and how it happened, right? To reconstruct the timeline in that forensic investigation will be vital, right? And then there was a speaker yesterday from Swisscom who introduced the concept of distributed tracing systems. This is another way we can capture operational intent. And this becomes like the system of execution flow, right? MCP servers can and probably should push to at least one of these systems, right? In reality, if this is some sort of enterprise MCP server that you're building, you probably should be pushing to all three of these things here, right? And if you push to all three of these things, depending on what your use case is for extracting data from this, you know what system to go to. Now, are you just trying to find out who did what? That's fine. If you're trying to figure out what happened and when it happened and what led to what, then it's a different system you'll use for that. So give yourself the options if possible, especially when building for enterprises. So those are the 4 principles, but that alone is not enough, right? This whole talk started with APIs kind of versus MCP. The truth of the situation is it's APIs and MCP, right? In order for the two to cooperate in harmony and give the agents the best chance of correctness, some evolution is probably going to be required when it comes to our APIs. Right? So API is always going to be the foundations, right, that MCP is built on, right? MCPs is going to be the hammer and drill that the agents use, right? And then the agents are going to use that hammer and drill to take actions on our behalf, right? So maybe our APIs need to become a bit more semantic, right? Maybe instead of just exposing these granular endpoints, maybe we start to expose sort of capability type endpoints that abstracts away that workflow into a single endpoint, right? And the advantage of that is if you look at some of the examples I've given before, in order for someone or something to invoke that workflow, there would be 4 RBAC permissions that you would need to grant for that, right? And that opens up a can of worms that we probably don't want to go into what could happen when it comes to reasoning agents. So if you were to go a bit more semantic, then we could probably have 1 RBAC permission. And in terms of what the MCP is going to need in terms of authenticating to the API, it's going to be a lot easier, right? Agents being reasoning beings, we don't want them to access the APIs directly, right? We don't want them to bypass the MCP server as well. So we should try to keep the authentication within the MCP server as well, right? By creating agent-specific semantics to match the MCP capabilities, that will help us a lot, right? It might even be possible that we need to introduce a new entity class, right? The common classes are users and service accounts at the moment. Maybe we need something like an agent account, right? These are some of the things that my colleagues and I keep looking at to see what is going on, right? So just wrapping up now, to summarize, these are the 4 principles of capability-oriented design. Just think about the capabilities, not primitives, intent-based interfaces, keep your MCP servers small, and try to capture the observable intent. I really do appreciate you listening. I hope you found it useful going forward. I'm Rob Barnes. If you want to connect with me, I'm mostly on LinkedIn, and that's my GitHub there. Feel free to add me. And thank you so much.